The question is about virtual machines. So first of all, you have to understand what a virtual machine is. There's actually a really good diagram on the opening Kubernetes page. If you click on Kubernetes architecture, it will show you the history of computing, and it takes you through the traditional server client architecture, and then what happened next was the virtualization of machines, so that you have not a real machine but a pretend one that's running inside of a machine, which can either act like it's in its own private network and the computer is kind of like the Wi-Fi container for the subnet for it, or you can actually make it act like it's like two computers separate into one, even though they're running in the same operating system. Actually, separate operating systems, same hardware. Chassis is another word that's come about lately because people have a hard time being specific in their language. So the word this is something that it's come about the last couple of months actually for me. In the cloud native world, there's more and more system administrators are using the word chassis, and what they're talking about is the physical machine that's going to house the hardware for the virtual machine or whatever. And they needed yet another word. They couldn't call it a machine anymore. You know, because so anyway, so whether or not you like virtual machines, and then after that is containers, right? So Docker containers, they're actually Linux containers. Docker got all the credit because Docker made a useful application that uses C groups and etc. under Linux, which is that was the thing since the 90s, but it got really popularized by Docker. And so that's kind of the history. And based on that history, the answer whether I hate them or not is absolutely do not hate them. I do not. I do not. I actually use them all the time. I do not hate virtual machines, but they are actually really good for testing things out. For testing things out as a developer, they're super good. Great for hackers, for 0-day hackers who want to find them. Just watch Gamozo on Twitch. She'll tell you all about it. C groups weren't around in the 90s. I know. Steve Schrute was around in the 90s. Thank you for the correction. And so, yeah, C groups came later. We had Schrute in the 90s. Thank you for Mac. I misstated that for sure. And I mean, but the germ of it was around for a while. So, okay. So what else do we got? We have, I mean, virtual machines are a good thing. They are definitely a good thing. They allowed us, they gave us, elastic, computing services. Whether you're a hacker who wants, a ton of computing power to crack a password over 20 minutes, or you want to be, and they do that, or you want to run a consistent service like Netflix or whatever. I mean, elastic computing that was largely championed by Amazon is a thing, and it's only a thing because of virtual machines. To be fair, the idea of a virtual machine predated VMware, who gets a lot of the credit for that. They made the first probably viable commercial product that did virtual machines, but there's been lots of others after that and before. IBM actually was doing LPAR virtualization for machines way earlier than that. And I remember in '98, the mainframe guys coming over and saying, "Hey, we got Linux on mainframe over here. If you want to log in and try it out." And they had basically carved out a piece of their mainframe and put virtual machine in there. So there's no reason to hate virtual machines. They're really good. The question might come from maybe I've expressed some dissatisfaction with having a virtual machine when one is not needed specifically for Kubernetes. So virtual machines can be bloat. And if you don't believe me, just compare Kind, which is built on Docker containers and simulates different nodes, which are machines running Kubernetes components. They're not real, of course, and they're just containers. They all share the actual same kernel, and that creates problems. But for all intents and purposes, for all the stuff you're doing with Kubernetes and Kind, you can do it that way. And in fact, it's so effective that Minikube, which was originally created as a Kubernetes tool, you read a lot about it on Kubernetes.io. Minikube was another tool that is built originally on top of a driver for a virtual machine above everything else. And very recently, the default is to now use Docker if detected. Docker is a container engine. And if there's one thing, if you're going to get into this space, you must be able to articulate the difference between a virtual machine and a container. And I'm not going to do it here. I'm going to let you guys figure that out. But absolutely make sure you can distinguish the difference between those two very quickly and succinctly. Hey, how's it going, Chad? We're going to do the Shark. We already did it. We can do it again later, though. You're testing out Talos. Ooh, with Proxmox. Proxmox is for managing virtual machines, right? So a lot of these tools that are out there, Terraform, Proxmox, what is it, OpenStack, and AWS and AWX and all. These are things for managing virtual machines because it's yeah. So these are the reason I bring this up is because for the last decade or so, if not more, I mean, predating the container craze, the Kubernetes craze, which didn't even start until 2014, 2015 or something, was this the virtualization craze. And so enterprise, and I'll describe my enterprise that I currently work for, which has over 200,000 computers assigned to do work in different ways, and more than half of that work is still batch, which means that those computers are, you send a job to them and the real computer runs that job as a protected container along with half a dozen other containers or whatever on the same computer. And the whole idea of taking the container and running it on any number of actual computers doesn't really require any virtualization. I mean, there's no virtualization. In some cases, though, you'll see the same exact thing. Well, there's somebody take a big old computer like that and they'll slice it up into a whole bunch of different virtual machines. And that's what tools like the ones I mentioned are for doing. And I have very little experience with that. I'm just gonna put that out there. I went right from my own business into the Kubernetes world. And so, virtualization, my experience with virtualization has always been as a developer using it to, I originally played Dota even on Windows or something like that, but, or to, run Windows apps on my Mac or Linux, right? Or run Windows stuff on a Linux machine, which I've done a lot, and so as a developer, there's a lot of value in having a virtual machine, but it does get pretty much bloated. This is not completely accurate, but you can kind of consider when you say, I'm going to have a virtual machine, you have to write off, 1, 2, 3 CPU cores, and those are sort of dedicated to it. Now, modern virtualization, I understand this is a relatively new thing I've learned. Modern virtualization doesn't say these 3 cores shall never be used by anything else ever. I guess they're better at allocating the resources dynamically than they used to be. But there was a time where if you assigned 2 or 3 cores to a virtual machine, it was like you literally took those pieces of hardware out of your computer and they were no longer accessible to anything else running on your host system. And that kind of commitment for a virtual machine is a big deal because, not just that, but RAM too, right? You have to say you're going to get so much RAM and this RAM is, thou shalt never access this RAM, and disk is not a big deal. It's just a big old file that they use as block storage. The point being that when you commit to a virtual machine on a PC or in a server or space or something like that, there's a lot of ways to change it up and reset it and all that, but it's a little bit heavier. And again, there's many more people that are far better qualified than I am to talk about this, but that's my understanding of it. So when it comes to Kubernetes, so there's been an operating system that I'm dying to try out called Sodero Talos, and that's not you're so limited. So I'm dying to. There was an article recently, and I have a reference to this somewhere in my Zettelcast, and somebody shared it with me while we were talking about, well, if I just want Kubernetes on my computer, why do I run a virtual machine? So this is what people are doing. They're coming into their data centers and they're bringing a new piece of hardware, like hardware, right? And they're taking a chassis and they're putting it into their center, and then they're immediately putting a minimal hypervisor, which is what you need for a virtual machine. And there's type 1 and 2. One is raw bare metal, and the other one is a software emulated one, which is slower. And and only the modern computers that have been built even support the Type 1 Speedy Gonzalez kind of. You don't know that reference. It's probably not even a politically correct reference anymore. Oh well. But they're like really fast, and and so they can do all kind of things. And then what? And then that entire thing now can no longer do anything but what it's done as a VM. Now, it can be added and removed from different pools. You can redo the entire OS if you want to, and that's what tools like Proxmox and AWX do. I mean, these open source tools, but and that's kind of your own cloud without a cloud. It's kind of like you have your own Elastic, Amazon Elastic, whatever. And that's all great and all, but then when Kubernetes enters the picture, and this is where, if there's any hate for me you've ever detected, this is where this comes in. So now you've got the situation where you have this machine, this hardware that is now being virtualized so that it can run any OS that you want at all. It has a hypervisor is a minimal OS, like a really teeny itsy bitsy OS, but it's able to run any number of other true operating systems down to the device level and everything. And so it can run a full operating system, right? So you can swap out, you can make that piece of hardware you have run whatever. I mean, you could have it run. I think you could have it run Windows, you could have it run Linux, you can have it run BSD, whatever. It depends on if the operating system supports it. Like, I don't know if you can do it with Apple because they don't release their OS. But the point being is that, yeah, you can swap out the OS on that piece of hardware that you bought and do whatever with it. And that flexibility is great. But as soon as Kubernetes comes into the picture, now you have a layer of abstraction and bloat that's unnecessary. And this is where vendors like Talos and Sidero are kind of trying to make their mark. And this is a relatively new thing from what I understand. Is it's like, let's see, hypervisor is more like a resource multiplexer, not like an OS per se. That's a great, thank you for that, Mac. Thank you for that. You would know. I mean, this guy's written his own OSs. Way more. There's people in my chat that are far more qualified than I am to answer this question. So I lean on him heavily to help me answer these things. I mean, he's an embedded engineer. He's doing stuff. But the point I'm trying to make is, let's say you decide, so you put a virtual machine on this, really fast hardware, and then what do? You say, Docker as a container, VM or to KVM machines, yes. So now you decide, I only want to run Kubernetes on here, period. I don't want anything to do with other than Kubernetes on there. So then you're starting to look at really low level operating systems like K3OS, or what's formerly known as Ratcher, or maybe any a stripped down version of Ubuntu Core or Fedora or Red Hat or whatever. And you're like, the only reason this even has an operating system is so that it can run a container engine, so that I can put a kubelet on there and call it a node in Kubernetes. And as soon as you do that, now you have a problem, because now you're like, well, this whole hypervisor stuff is just unnecessary bloat. It's unnecessary abstraction. And the article that was posted, and it's in my Zettelkasten, so maybe I'll find it for the notes here eventually. But the article stated that on average, that Kubernetes running on a hypervisor, which means in an OS that's running a hypervisor, gives you 30% less performance. And I work for a high performance computing machine learning group. And so the idea that you would run a hypervisor on top of your kick-ass hardware and then run just Kubernetes on it is so wasteful, it's unthinkable. So that's not hate, it's just efficiency. And it's also the core reason that I'm so fascinated by these new ephemeral operating systems that are coming out, that, like the one from Talos, it's the only one I know of actually, and Sidero is the name now. And because all it is an operating system that runs on that bare hardware that has no other way to communicate with it other than gRPC over MTLS from a single port, and it can only be controlled from a command line or a dashboard or something. And that means that the actual hardware of the thing is fully and totally dedicated to running Kubernetes and only Kubernetes. And therefore, the container engine is built into it by default. It's more turnkey. It can't be hacked, because if you hack it, there's nothing to hack. Everything's just read only on the file system. Other than PVCs and persistent volume claims that are managed by the kubelet and everything, as would be with any sort of Kubernetes node. So to me, that's not hate. That's just a a lack of appreciation for wasted resources. How's that? I guess that's hate. I don't. I hate virtual machines for Kubernetes. When people put Kubernetes on a virtual machine, it just drives me nuts because and yet that's what they ask you to do in Minikube, and that's what they ask you to do in if recently I've changed my learning path with Kubernetes to just use Raspberry Pis and leftover hardware that I have around. Because why? Because the alternative is for me to buy like a $5,000 Threadripper and then carve it up into virtual machines that I can deal with locally, or pay a crazy amount of money for cloud services over time to get that kind of thing. I mean, even like a teeny itsy bitsy DigitalOcean, what do they call them? Droplet is still $5-10 a month, right? So if you want to simulate a Kubernetes environment, you're talking about you're talking about at least 3 control planes to get high availability to emulate that. And then you're talking about 3, 4, 5 worker nodes. You're talking, 10, 15, maybe 16 virtual machines, and do the math. You're now paying how much a month just to have a Kubernetes environment. And this is why all of the cloud vendors, including DigitalOcean, have offered, they have a $10 a month Kubernetes environment. And it's kind of this black box in terms of Kubernetes. You don't know what it is, and which I have to test because I don't know what that means with Node Affinity. How can I test my GPU jobs if I don't know if I have a GPU or not, that kind of thing. So when it comes to Kubernetes, being able to test it and play around with it and stuff, I think having a local high-powered server with a Threadripper or something that's got crazy amount of cores and RAM, especially RAM, is probably a good way to have a virtual lab that you could stream and do things with, and would spend the least amount of time screwing around with. But you would still have to allocate the virtual machines and then clean them up and reap them and everything, and that would save you time for sure. But if you've got that kind of hardware laying around and you're not really into like remaking one of those, into a different operating system without, downloading a flash drive and putting the image on the machine the hard way, the old way, then that would be the thing. I mean, a lot of people would suggest that that kind of home lab, the way you should do it is you should take all of this really slow old hardware. I mean, can you imagine me running a virtual machine on a Raspberry Pi just so I can run Kubernetes on it? No, it doesn't make any sense. And it might make it from the administration perspective, it might make it seem faster to administer and everything because I can swap out that Raspberry Pi to be, some version of some slimmed down ARM OS or whatever is out there. And I can swap it out anytime I want. And that flexibility might be fun and all, but how much time am I really saving from just walking over to the thing and changing out its SD card, or something like that. So virtual machines definitely have a place, but from my experience so far, it seems like some companies just there's no real reason for this conclusion. They're watching people and reading and stuff. It seems like there are a lot of companies that are still pretty heavy they've invested a lot in the virtual machine approach, and they're still there, and that's fine. They're going to be there for a long time. But I think that ultimately, I think that Kubernetes on virtual machines, virtual machines is not optimal, bottom line. So, I run into this enough to be annoyed by it, not to mention the fact that I had to make a decision for my own training in my own home lab. And I've decided, against virtual machines. I actually spent a great amount of time trying to make a Docker host container that can run systemd so that I can do what Kind does, which emulates your environment as close as possible, including, apt installs, messages, and all that kind of stuff, in a way that is 100% consistent with how you would, I can run kubeadm on there to do init and join and all that stuff. As long as I can do those things, I can practice the steps necessary to do most of my training for Kubernetes system administrator. But the fact of the matter is that I've actually decided to do all hardware for my training because you're doing more than that. You're when you're setting up volume claims and stuff, you're also considering, network attached storage. You've got to have some sort of load balancer that's not even involved in Kubernetes. and you need a lot of things that are not related to that, and those are hardware things. And those hardware skills, those sysadmin network engineering skills, those are a solid part of the job requirement as a cloud native infrastructure engineer, or whatever you want to call it. And I did a video about why I don't like the term DevOps earlier. So to me, yes, you need to know them. You need to learn them. They're particularly good if you're a hacker and you need to break Windows and figure out how to break it without and reset real fast. Or if you want to test out different versions of Linux distros and you're a beginner, I recommend beginners install Linux into their virtual machines, specifically VirtualBox, as often as can to try before you buy. And then when they get into it, they can actually boot their core, their Windows OS and put whatever Linux they want on there. So in all those, for all those reasons, I don't hate virtual machines at all. I don't like virtual machines running Kubernetes in a production environment. Bottom line, I just think I think that's a mistake, and I think that happens a lot. I think a lot of people do that, and I don't think that the hypervisor is required in that case. In fact, I think we're going to see a migration away from it. Frankly, I think we're going to start to see a lot of net boot happening. Again, we're going to be a resurgence. I'm going to predict. I'm getting kind of people are getting kind of fun with me on this because I've been predicting things correctly here. I'm going to predict today publicly that we're going to see a massive migration back to net booting and away from virtual machines with Kubernetes going closer and closer to bare metal. There's going to be less and less need to virtualize that hardware and more of a need to boot a frequently updated operating system from a common source. And that is the same sort of net booting we've been doing since the early days when we were running, college labs and wanted to do it that way. I predicted that we're going to see a lot more of that. And so if you don't know how to set up a net boot server and a boot image and boot up any computer off of the network by just turning it on and changing the BIOS setting, you probably want to think about that. Sidero is exactly one of those things. And Sidero and Talos, this is why I'm so fascinated by this movement, whether or not they are the first or not to, I think that where they're going is the future, hands down. I think the dollars are going to decide that that's the future because it's more effective. It's easier to manage. The real kicker is going to be, can they get, right now Sidero does not have GPU support, and no machine learning cluster is going to even look at you until you have current, if not, pre-current or support for all possible drivers that could ever come out from NVIDIA and anything like that. And that's tough because those operating systems are Linux, and God knows NVIDIA doesn't like to play with Linux. If you don't believe me, go watch Last Miles Dennis go talk about that one. So yeah. Metal as a service solutions for Kubernetes. Absolutely. It absolutely is. Yep. And we've talked about it a lot. And I actually had a meeting with the people that run Sidero, and they've been very kind. So they're actually looking forward to me trying this out too, I think, as a total noob. It'll be fun. So stay tuned. That would be coming up later. I'm just going to put this here. I predict virtual machines will diminish in popularity, and for Kubernetes will diminish, and I'm really looking at net boot options like Sidero / Talos and stuff. That's all I have to say about that. That was quite a long answer. I thought it would be shorter than that. I hope that gives you some context.